Welcome to this tutorial on C++ forward lists. Forward lists are singly linked lists that are part of the C++ standard library. In this video, we'll explore what forward lists are, how they work, and when you might want to use them. We'll also look at some code examples to help you get started. So what exactly is std? Forward_list. It's a container that implements a singly linked list. This means each element stores a value and a pointer to the next element in the sequence. Key characteristics are: it is a part of the C++11 standard library. It's optimized for forward traversal, as the name suggests. It's also more memory efficient than std list because it only maintains a link to the next element, not the previous one. However, it does not have backward traversal capability. The code example shows how to include the necessary header, which is forward_list, and how to create a forward list of integers. It then iterates through the list and prints each number. Now let's explore some common operations you can perform on a forward_list. We have operations like push_front, which adds an element to the beginning of the list. Then there's pop_front, which removes the first element. Insert_after inserts a new element after a specified position. Erase_after removes the element after a given position. Before_begin returns an iterator pointing to the position before the first element, which is useful for inserting at the beginning. Splice_after transfers elements from another list into the current list, and remove_if allow you to remove elements based on their value or a specified condition. On the right, we have a visualization of these operations. The initial list contains the values 5, 8, and 3. After performing a push_front operation with the value 7, the list becomes 7, 5, 8, and 3. Lastly, insert_after inserts the value 2 after 5, resulting in the list 7, 5, 2, 8, and 3. Iterating through a forward_list is straightforward. The first method uses a range-based for loop. You can simply use a for loop to access each element in the list. The second method uses iterators. You can obtain an iterator to the beginning of the list using numbers.begin and iterate until you reach the end, which is numbers.end. Remember that unlike std list, forward_list does not support backward iteration. Additionally, there is no size method available, so you have to iterate through the list to count the number of elements. Before_begin returns an iterator position before the first element. The std distance function can be used to find the number of elements between iterators. Iterators are only invalidated when the referenced element is removed. Modifying elements in a forward_list involves using methods like insert_after, erase_after, and remove. To insert an element, you first need to get an iterator pointing to the position before where you want to insert the new element. After inserting, you can use erase_after to remove the element after a specified position. Remove removes all elements with a specific value. On the right, we have a comparison between forward_list and list. Forward_list has lower memory usage, but doesn't support bidirectional iteration, the size method, or push_back. Both have the same insertion performance with big O of 1, given the position is known. Forward_list is ideal when memory is constrained and only forward access is needed, while list is preferred when bidirectional access is required. Let's explore some advanced operations with forward_list, such as splicing and sorting. To splice lists together, you can use the splice_after method. This transfers elements from one list to another at a specified position. In the example, list 2 is spliced into list 1 after the first element. After splicing, list 2 becomes empty. You can also sort a forward_list using the sort method, which arranges the elements in ascending order. Some other useful algorithms include merge, which merges two sorted lists into one, and unique, which removes consecutive duplicate elements. Remove underscore if removes all elements that satisfy a given condition. Keep in mind that forward underscore list does not have a reverse method. If you need to reverse a forward underscore list, consider using std list or implementing a custom solution. When working with forward underscore list, there are some performance considerations to keep in mind. In the code example, we define a structure called person that contains a name and age. We create a forward underscore list of person objects and add 2 people to the list. To improve performance, use forward underscore list when you only need forward traversal and memory efficiency is critical. Keep track of iterators to avoid big O of n traversals when inserting at specific positions. Memory usage is approximately the size of t plus the size of a pointer per element. Insertion and removal operations are big O of 1 when the position is known. If you need bidirectional traversal or the size method, consider using std list instead. In summary, std forward underscore list is a singly linked list optimized for forward traversal and memory efficiency. It's ideal for scenarios where memory usage is critical and only forward iteration is needed. All operations are performed with the underscore after suffix due to the forward-only nature of the list. There is no size method available, so you must iterate to count elements. It provides efficient sort, merge, and splice underscore after operations. Consider std list if bidirectional traversal or constant time size access is needed. For further resources, you can refer to the C++ reference, the C++ standard library documentation, and resources on STL algorithms. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.